Very cool. So now that we are loading the section normal based on that base faces, I just want to draw quickly these normals, and I think that that should be done. Let's just say, remember how we have this render track section function that goes and asks to render those faces? I think after I draw all the faces, I can come here and I can say, let's say that we have something, we're going to create something called draw section normal, right? So we're going to have, let's say, a draw section normal. Let's pass the section pointer that we want to draw, and then we are going to have here up. I'm going to go ahead already and paste the function that I have, which is this one right here. Render section normal, I pass the section pointer, and I also have to pass the camera because section and camera, I have the camera that I pass as parameter, no problem. Let's see what this function does. So render section normal, passing the section and the camera pointers. I have 3 vertices, I have I, O, T, Z. So look, this is exactly what we did. Remember when we were drawing those axes, X, Y, and Z for the orientation? I am going to do exactly the same thing. I'm going to have 2 polygons, one that is rendered at the center of the section, and pay attention how I also need to perform that translation with the camera, right? Exactly the same thing that we were doing with our track. I need to always remember that. For me to find the correct point in space that I have to draw my first polygon, it has to be offsetted by, right, subtracted from the camera position X. So I go from this polygon A is a very small triangle at the section center, right, minus the camera position, so it's the section center, this is the origin of my vector, and I perform the RTPT, translation, projection, all those things. So this is basically just us adding a little polygon. And then I have another polygon that is at the tip of the vector. What is the tip of the vector? Well, it is going to be V0, 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 X, Y, and Z. Is going to be, and I'm clamping 16 bits just because, is going to be the section center minus the camera position. So I'm going to go to the section center, right? I have that center position, plus the normal of the section, and I'm just dividing here, shifting by 3 to shrink a little bit that normal. This is going to be the tip of that normal vector from the center until that normal vector tip. I perform the RTPT and the projection of all these 2 polygons, polygon A and polygon B, from the base of the vector and the tip of the vector. And then all I have to do, now that I have these 2 points in space, the base and the tip of the vector, all I have to do is draw a magenta line for the section normal, right? A little line between A and B. So set line F2, XY2, I set polygon A and polygon B, the start and end points of my line, I set an RGB magenta, and I draw my line, right? I draw the primitive line. This thing right here, if we compile and we generate our CD ISO, oops, load track sections, J undeclared. Oh, rookie mistake. So I think render track section, I think is when we were loading the track section, correct? Which is up here, load track sections. Yeah, we are using this J. I need to declare J. Is that it? No, draw section normal. Right, so it is not draw, it is render section normal. I think the name of my function, is that correct? Render section normal. You know what, let's just call this draw section normal. And then I have a draw section normal here at the end. Beautiful. I think that's it. Cool. Now that everything compiles, let's just quickly go ahead and load our game ISO. I hope to see my normals of the track. Look how cool that is. So they are all going from the center of the section, right? This is the polygon A, this little small point here, until the tip of the vector, which is in this direction of the normal. I just go and remember how I shrink by shift 3 bits, but yeah, this is how long I wanted this normal to appear. So now we have all these normals, and if we go, the normals of my sections, right, which are based on, they are all based on the normal of that track base face for the section. Right, so there you go. You see the normal, we can go up, the normal changes, super, super cool. Right, so that is cool. I just wanted you to see that we do have now the normal per section. And that is super important for us to visualize things, right? Let's say that you have maybe a debug flag that whenever you set that flag on, then you can see the normal of the sections, the normal of the faces, or even the axis of orientation of the ship, things like that, right? So this still doesn't answer our question, and it doesn't solve our problem of attracting the ship to the track, but we're going to get there, right? Do you see? The normals are going to change as we go down. Super, super cool. Right? Normal vector, super important concept. We can use this normal vector now to find the direction of those forces that we have to apply, right? Or how tall and how high is the ship compared to the track base, right? So let's just think about that. So in the next section, I want to talk to you about, well, basically those two forces, right? So how are we going to find what is the height that the ship is based on this track base, right? So how tall are we, right? So how high are we, and how much do we have to pull, or how much do we have to push, so the ship is always kind of in a certain offset from the base of our track? That is what we're going to tackle next.